Hello and welcome to Quadratic Inequalities. See, here we have a quadratic equation, and instead of it being equal to 0, it is now less than or equal to 0. See, normally we're doing our graph, we've got some kind of quadratic parabola thing, and if it's equal to 0, we're trying to find out where does it equal 0, right there. But now we're asking where is it less than or equal to 0. So in this one, all of these points would be all the places where it is less than or equal to 0. Sometimes we ask where is it greater than 0, and that would be all of these x values and all these x values. So we typically look in three zones. We look in a zone here, we look over here, we look over here to the right of this x-intercept, and we look in the middle to see if it makes the equation work. So that's kind of the picture of what we're going to be doing. Alright, so the first thing here is we want to find the x-intercepts. We want to pretend like this is equal to 0. And so we're going to have to factor this. If you remember factoring, we take first times the last. That adds up to be the middle. And that's going to be negative 5 and negative 4. And those should have x's. This is x squared. And this is x2. Now, if it was not a 2 there, if it was just an x, then I could go straight to x minus 5, x minus 4. But that 2, remember, means that I have to do my area model here. And I have to put in my 2x squared, and I have to put in my 10, and then these guys go in here. And now we just get around the outsides. Wait, this is squared. So to get around the outside, let's go x and 2x. Let's make that negative 2 and this negative 5, and that multiplies right. So my factored form here is going to be x minus 2 and 2x minus 5. And that is all less than or equal to 0. Now I'm going to pretend that it's equal to 0 to get my boundary points. So if it was equal to 0, I could use zero product property. This one, the boundary point, the thing that makes that 0 is 2. And this one, remember we would set 2x minus 5 equals 0, so 2x equals 5, and x would be 2.5. Looks like, so our boundary points would be positive 2 or positive 2.5. So we look at where that falls on the number line. Here's 0, here's 2, here's 2.5. Those are our boundary points. So what we're going to do is we're going to test something that's in here, something that's in here, and we're going to test something that's in between and see where does this equation work. So first I'm going to test x is less than 2. Over here I'm going to test x is greater than 2.5. Actually, I can make those equal to. And in the middle I'm going to test x is between 2 and 2.5. So over here, I pick any number that's less than 2. If I get the chance to pick 0, I'm going to pick 0. So I'm going to test 0 here, and I'm going to plug it in to this equation. 0 minus 2, and that's going to make it 0 minus 5. So that's going to be negative 2 times negative 5, which is 10. Now, is 10 less than 0? No, so this doesn't work. It does not work. We can use x's, we can use frowning faces, some way to represent that this does not work. Over here, let's pick a number that's between 2 and 2.5. How about 2.2? I'm going to test that and see what happens. So I have 2.2 minus 2, and here I've got 2.2 times 2, which is 4.4 minus 5. And that's going to be 0.2, and this is going to be negative 0.6. And if I multiply those together, that's negative 0.12. Now, is that less than or equal to 0? Yes, it is. Some people like to do check marks, some people do smiley faces, something like that. Let's pick a number over here that's greater than 2.5, any number we like. How about 10? That's kind of an easy one. So 10 minus 2, and 10 times 2 would be 20 minus 5. So that makes 8. This will make 15, which is 120. Is that less than or equal to 0? No, it is not. So the regions where it works, the only place it works is right here. So I write my answer to say the values that x can be are between 2 and 2.5. And then I put that on my number line. Here's 2, here was 0, here was 2.5. Because it's equal to, it's a closed circle. And equal to is a closed circle, and we're going to shade in between on this one. That's saying that the place that this parabola goes below 0 is between 2 and 2.5. So it's probably a picture of something that looks something like this. Here's 2 and here's 2.5, and it's coming down like this, and that's the part where it's below 0. Okay? One more example. Something like this. This is a bit easier because it's a shortcut type. There's no number in front. So I'm just taking things that multiply to be negative 16 to add up to be negative 6. Okay, that's negative 8 and 2. And for this one, I can go straight to my factored form using those factors. So, again, I pretend like it's equal to 0. I find my boundary points. This one is 8. This one is negative 2. So let's think about my number line. I'm going to pick something down here. I'm going to pick something up here. I'm going to test something that's in the middle. So let's go less than negative 2. Let's go greater than 8. And let's go in between. Something like this. So my less than negative 2, I pick a number. Let's pick negative 3. So negative 3 minus 8. Negative 3 plus 2. That's negative 11. This is negative 1. That makes 11. Oh, look, that's greater than 0. That's true. Okay, so let's do smiley face there. That one works. Okay, so let's pick something in between here. How about 5? No, I can pick 0 because it's in between. That's easy. I like testing 0. It's easy. 0 minus 8. 0 plus 2. And is that greater than 0? That's negative 8. This is 2. That's negative 16. Is that greater than 0? No, it is not. That is negative. It's not bigger than 0. That's a mistake on my smiley face. Up here, let's test 10. I'll do a different color. 10. Something bigger than 8. Anything you want. So 10 minus 8. And we've got 10 plus 2. All greater than 0. That makes this 2. That makes this 12. That makes that 24. Is that greater than 0? Why, yes it is. So the places where this works are here and here. So I'm going to express my answer as x can be less than negative 2, or it could be a number that is greater than 8. I put that on my number line. Here's negative 2. Here's 8. I'm going to be shading open circle and all the way down, open circle and all the way up. I like to put arrows on it to show that it keeps on going. This is what your answer should look like. Again, the way our picture might look here is we've got some kind of parabola, and we're showing that the values from negative 2 on down is where the parabola gets bigger than 0, and from 8 on up is where the parabola is greater than 0. Hope that helps. Have a great day.